Okay.
Hello everyone. Am I audible?
Sir, you are audible.
Yes, sir. Yes, sir.
Okay, so we have with us our first speaker, Dr. Sabyasachi Ghosh, who is an expert in the field of quantum mechanics, nuclear physics, and particle physics. And he will be speaking on the very fundamental aspects of the topic at hand, the photonics, that is the journey from light to photon. Dr. Sabya is our own faculty member here at IIT Bhilai. Before that, he did his PhD from VECC and a couple of postdoc stints outside India. So he's an expert in this field, in the fundamental aspects of quantum mechanics. And I would now hand over to Dr. Sabya.
Thank you, Mahavir. So let us start. So I'm audible now.
Yes, sir.
Thank you.
Yes, sir. Yes, sir. Good morning, sir.
So the title is the journey from light to photons. So these lectures, actually, I will try to take you the different conceptions or transformations in the physics from the light concept to photon concept, and I will go step by steps, but with a very positive and very not I will enter to too much details calculations of those things. My idea is just to give you that how this our physics historically goes through those transformations. Okay, but okay, but just starting with the main topics, actually, I want to waste the times with the 3 slides regarding the time axis. So, because this time axis is very necessary to orient nowadays, because nowadays we know the scientifically that from where to now we are here. So as you know that the universe age is 13.8 billion years. So actually we have to keep in mind the scale, the 1 billion mean what. So it is a huge number, 10 to the power 9 years. So 10 to the power 9 is also not very hard to see, but actually if you put this 0, 0, 0, 0, 0, then you will feel the actual how much big this. And you know that our Milky Way, the age is 13.6 billion years, Sun is 4.5, Earth is also. So just if you just scale this in a log scale, this time axis, actually if you do in linear scale, then it is very difficult to see this stepwise. Now from this log scale, probably you can see. So this 13.8 billion years is comes to this zone. And actually if you see this red circle, so if you zoom this part, so in this part actually you will see the life cycle of Sun from his birth to present, and means our solar systems. So we should keep in mind before that nothing is there regarding the solar system. So if there is no solar system, then there is no human being, there is no civilizations, nothing. If people are interested to know these things, maybe this YouTube link you can click later. So this is in Hindi, but in English version is there. If you search, then you will get it. Now, with respect to, so actually this 4.6 billion years is still is huge. Okay, that the age of the solar system. And with respect to the human civilizations, if you start with, it start near about 5 million years ago. So you can understand it is 1 by 100 kind of things. So actually why I invest these time axis things, because it is the faculty developing programs, and actually I think that the faculties should get interested to orient the students to this scientific, whatever the time scale, actually it is well standard, it is in Wikipedia, we know it. So if you make oriented in this way, so this is a very beautiful scientific update for the students actually. And we can also motivate them. Probably there is a very nice movies also on these different ages, so we can recommend them to see those movies, so that they can get the feelings. Okay, the actually whatever nowadays the huge development comes, but which time scale we are now. Okay, so after spending this time scale things, this is the last slide of this time scale things. This is very interesting things. If you see in the Wikipedia link, this is called the cosmic calendars. So actually, if you feel very hard to understand that actually this 13.8 billion is a huge. Okay, so there is an interesting calendar. You can convert this 13.8 billion years to a 1 year. Okay, because this 1 year feelings is very close to our senses. What I did in January, what I did in February, that's very close to our feelings. So in that sense, if you think that our universe is created at the beginning of January, then you will see the January to up to September, there is a no story about the solar system. The solar system is created in the Septembers. And the entire story, so I'm not going to the details of these things, but if you go to the Wikipedia link, if you invest some time, 1 hour, maybe you will really interesting that if you can motivate the students actually what are the whole time scale of our human beings. Very interestingly, that last 60 second of the 31st December, the whole human civilizations is started. Okay, so if you convert that 13.8 billion years to the 1 years, you will get that kind of feelings. And maybe the last 10 second or 15 second or 5 second, you can think that real scientific development of the physics actually it started. So after knowing this time axis, so let us come to our original point, the light. So if you try to find for light also the try to find the historical things, then if you try to find the ancient light for universe, then it is first actually light decoupled from this universe, that is the 560 million years ago. And these stages actually from the Big Bang to this 560 million years. So this every stages are really interesting. Research is there and interesting stories there, but that is itself a separate talk. People can listen. Maybe there are different YouTube links also from where you can get. But I'm not going to that things, but just to, if someone say the ancient light of the universe, it is first light, actually it comes, at least information wise, we should know it is 560 million years after the Big Bang. But as you know that actual human being discovered the first light in the jungle there. So this time is very close to now, you can think, but still not close. It is 1 to 2 million years ago. So now, if you really see when human beings started to think about light, okay, so then the time scale which comes, which is very small time scale with respect to the universe time scale, but let us focus our own time scale now. So it is uh, uh, ancient Greece time. Actually, this great fellow, the Socrates, Aristotle, they already started to think something about light. Although their thinking present days is not valid, we know it is not very updated thinking, it is backdated, but still the the beginning of the thinking is really appreciable, because they really started, actually they try to think, okay, not just use the fire or not just use the lights. What is light? And the questions came from them. But actually scientific questions, if we see the answer started, real scientific answer is started, so that this durations is the real time, that 1600 to presence. Okay. And probably and this zone near the 2000s, actually there suddenly the applications of this, after understanding properly this light and photon concept, this zone, actually the applicable is really an avalanche. So we may think this 1960 to present is the photonics timeline. But my job in these lectures actually is take you from this period, that 1600 to this period, that 2000s. So there, how this journey of the conception of light to photons, how these transformations goes. Okay. So the ancient questions was that what is light? Okay. So if you tell, if you historically find that when the questions in 1600 times, actually when people try to think, so there actually they think in different way. Okay, don't think too much deep. Just consider it as a ray, something is flowing. Okay, and just focus on its directions, on the geometry, where it goes, light comes from where and went where, something like that. Okay. And actually very interesting laws people have discovered, just focusing only the directions of light. So for light is just a line. Okay, what is made of, at that times they are not curious, maybe curious but not find the answer. So the directions wise, they see that when light goes from light medium to dense medium, its direction is changing. Okay, and we know that actually this famous Nernst law, actually that describe that, which how these directions is changing. And the famous Fermat principle also, that its idea also in that way, that suppose light is from one point to another point, and light is trying to go in through the optimized path. So if you take the optical path length, and if you optimize it, then actually you can detect that light will go from where to where. So this way at that times, so this timeline you can understand with this scientist durations. So in these days, some device also, maybe this device discovered in very earlier stage, the lens, mirrors, and at that durations they tried to find that actually how their directions and geometry, if they can quantify, and they can get the very beautiful laws. Actually we know that this we will learn in our 10th standard courses. So gradually people try to go more deep. Again the question is same, what is light? It was the famous scientist Huygens. He is first time tell that it is a wave. Okay, just like the sound wave, we know that some quantity is fluctuating. Similarly, here is also some quantities fluctuating with space and time. And we know this is the branch of the physics, the physical optics. So in that time, the interesting discovery is, it is interesting, but still it is something was missing. So for sound wave, actually we know that the sound actually need a mediums, and when you pass through the medium, So the medium will expanded or densed. Okay, it will oscillating, and it is a longitudinal wave. So ultimately, you can think that basically the pressure is the quantity which is fluctuating with space and time, and it comes to your ear, and it makes sense with the sound. So similarly, Huygens thought probably some quantity is fluctuating. So at that time, they don't know the some quantity. So some quantity is fluctuating and coming to your eyes. So actually, that is something related with the light. So the same equations, whatever the for sound wave, actually you can write that as the quantity which is fluctuating. If you say it is y, so y is the function of x, and you can write it as a sine kx minus omega t. So a is the amplitude. You can understand the maximum displacement of y, and k and omega is carry the wave informations. The k is called the propagation constant. It is 2 pi by lambda, that wavelength, that is the distance between two same phase. And omega is the 2 pi nu. Nu is the frequency. Frequency means in 1 second how many times it oscillate. So actually, how Huygens prove that this is wave? Okay, so there is a interesting phenomena which is called the diffractions, interference. So they are actually basically proof. They are basically possible for waves only. So if you superpose two wave, you can see this phenomena. And how you get this, how you can say that this is the by measuring this quantity, I can say this is diffractions or this is interference. So for that, actually we have to focus on the amplitude. So for any wave, actually the amplitude remain the constant of space and time. It is the age just a constant. Okay, and actually with your ear, if you get the sound wave feeling, that is the basically the intensity of sound, that is basically amplitude mod square. Similarly, for light, don't know which quantity is fluctuating at that time, but again it is the amplitude mod square. So it means if amplitude is constant, then your constant, so your brightness actually measuring by this a. So now if we make the amplitude as a function of space, it means your brightness will change space. If you somehow it, then you can say if we superpose two things and if we get the amplitude is functions of positions, then it should be wave. Okay, so similarly for light case, actually the young make a experiment, the double slit experiment. They make a two source light. There is necessary the coherent source, so I am not going to this technical terms. But if you superpose this superpose these sources, actually the amplitude will be the function of positions. That is why your brightness will change with positions. Means your brightness somewhere the more brighter, and somewhere you will get the dark. So dark bright kind of fringe you can get. And if you plot the intensity, so it is intensity goes to the so if one wave have intensity I0, it goes to 4I0 maximum, then decrease, then 0, then again 4I0. So this kind of patterns actually nowadays in undergraduate labs also we can there is a practical labs also for this, and it is very well-known phenomena. But at that time, this Huygens and Young goes through those experiments, and they proved that actually we have to accept light is wave, although we don't know that some quantity is fluctuating. Which quantity is fluctuating? That at that time they don't know. So some resources, if you want, maybe huge resources you can get from the Googles, but if you want to see some YouTube lecture notes. Then English, you can see this Walter Lewis. There's lots of lecture note on the physical optics, as well as the Professor A.C. Verma. Also, you'll get some lecture notes in the YouTube link, and very good demonstrations of these reflections or refractions of light. So next step. Okay. So again, questions remain same, although we understand that light is wave, but questions repeated again, what is light? Because now we understand where is our knowledge deficiency, that which quantity is fluctuating. So actually, historically it goes very interesting. That interestingly, the answer was hidden in the different branch of physics, the electricity and magnetism. Now we are oriented, but at that time there is no link. Electricity and magnetism is a completely different branch, and optics is completely different. So in this electricity and magnetism branch, actually we know that it is related with the charge particle and their dynamics, and there's field is created, and with this branch, as with different earth-breaking work actually come historically one by one. That is for the interest of the development of the electricity and magnetisms, and the basic ideas actually historically developed. But those fellows, this Gauss, Faraday, Ampere's, those fellow, and there are many other scientists also who developed these branches. But those fellow don't know is there any connections with these branches with the optics or not. But this is this James Clerk Maxwell, who somehow you can say that accidentally just playing with these four equations of the electricity and magnetism and make a sandwich. Suddenly he discovered there is a connection. So electricity magnetism is related with the light. And if you briefly try to understand what is this four equations, so it is this first two equation is basically the electrostatic and statics. So it is about the if you have a static charge density. So we know that surrounding there is a field which is called the electric field, and if you want to know the direction electric field in which directions it goes. So if you see those figures, so it depends on the charge density. It is very simple, just a plus charge and only a minus charge. Its field of lines looks like that, but it's a complicated charge density. Accordingly, if you solve these equations, it will react accordingly. Similarly, that divergence B equal to 0 means the magnetic field of line. Okay. And interestingly, that magnetic charge is always in dipole in natures, not like the electric charge. That is why it is 0. You know that your field of line always create and close loop. So these are the things which is related to it when the charge is statics, when the electrostatics and magnetostatics. But when you start to dynamics, that your charge is moving. Okay, so there is really one earth-waking relations came, and it is by the Michael Faraday, that if you change the magnetic field flux, you can actually create the electric field. Similarly, if you have a current, your charge is moving, this mu 0 J. If you have a current density, then this current density always have a magnetic field. So just like this this wire, there is a current. So always around the space, you can get a magnetic field. So if you use the magnetic needles, you can see. So wherever you can see the current in near space, actually, the magnetic field is oriented. So those thing is that the strength might be different depending upon the current, but actually there is a non-zero value. So if you have to choose the device which can detect those things. So those things, nothing related with the light, nothing related with the optics. They are basically says about the charge and because of charge, the electric field, and how the magnetic field, how their directions, how it will, and how they have a geometry. If it is a moving charge and moving magnetic, then how it looks like. Okay. Uh, so those four equations, there was one missing. So that terms actually additionally Maxwell put it. And when after putting this additional terms, when you just put that there in the free space where there is no charge density rho and there is no j, so if you put that part and that part is 0, then if you do this, then and if you make the sandwich between these four equations, so there is few steps algebra. If it immediately you can get very interesting equations, and that equations actually people are acquainted as a wave equations. For sound wave, actually these equations they know. Okay, so these equations is a the twice space derivative and twice time derivative with respect to the fluctuating quantity. So for sound case, actually it was the pressure difference, and they are these equations are well known. But suddenly, when Maxwell tried to play these four equations, and he get electric field and magnetic field follow the same wave equations. And most interestingly, this is the place of the sound velocity. So most interestingly, this place actually these terms 1 by root over of mu 0 and epsilon 0. So it's the permeability and permittivity in vacuum. It came, and people never tried to multiply them, okay, and take a square root and 1 by. If people do it, then they can see that this value actually it is exactly value of the speed of light, 3 into 10 to the power 8 meter per second. So these things it's really heartbreaking discovery that then Maxwell realized that probably what is we are searching, that which quantity is fluctuating. So these questions probably we get the answer, that what is light? The light is the fluctuating electric and magnetic field, and how they fluctuating actually, if you go through this cartoon, that electric field and magnetic field, they are in transverse in natures, and light is propagating in these directions. So why this transverse and other things? So actually from those calculations, it is established. If you go to the branch of this electromagnetic wave, which is now is documented as a subject, the electromagnetic theory, the EMT, there we knows this fact, and that she visualizing the light is completely different after this Maxwell, and every the incident light, reflected light, and other things they can now able to explain with this electric field and magnetic field. And we really get a very broad band of knowledge about this electromagnetic wave. So we actually confined with only the visible range, that the VGOs that rate to violet. But beyond that, and beyond that frequency, and below that frequency also, this electromagnetic light can be possible. And we know that the different and the names of the electromagnetic waves: infrared, X-ray, microwave, radio wave, and they have a large band of applications. But ultimately are basically electric field and magnetic field fluctuations, and they were fluctuating in different frequency. When I means in 1 second how many times it fluctuating, that is different, and their wavelength are different, but all are moving with the same speed, that the speed of light, that's c is 3 into 10 to the power 8 meter per second. So it seems that we solved the problem. We know what is light. But suddenly we we understand our failure. Just simple sunlight, if you measure it, and if you see their spectrum, the spectrum we cannot explain with this simple knowledge of light is a wave. It is some quantity is fluctuating. Okay, and so sun actually we can understand. So the radiations is coming. Okay, so if you measure the sun wave outside the atmosphere, then that measurement is more pure. But if you measure in this sea level, then through the year there's lots of things can happen. So this curve, actually this blue line, so if you take this in the sea level, but if you outside the air layer, so this yellow line is the actual spectrum. So roughly, if one can fit, so actually it was done by the Wien. He somehow empirical gets some formula and they can fit, but it is just a empirical parameter fitting formula. But people are trying to find, okay, what can explain this curve. So this is also famous known as a black body radiations. Artificially also we can create this spectrum. Okay, because if you create the artificially, the spectrum will be more accurate. For sun is lots of it is not very accurate. There is some noisy things also, because we cannot ideally consider as a 100% black body a sun as a black body. But still it is this is the if we this is the questions actually related the origins of light. So light is coming from somewhere, so how it created, so that questions actually is hidden with these problems. So although in the classical electrodynamics we get one answer that if you accelerate the charge particle you will get the light, because light is the electric field and magnetic field fluctuations. But with this wave concept, actually, when you go, then we fail to explain. So actually, at that time, we know the thermodynamics of the waves. So the classically how it deals the Maxwell-Boltzmann distributions. And with that, the Rayleigh and Jeans tried with this concept, but they failed. They just able to fit only this part, but their curves are diverging. Okay, so it means this simple classical electromagnetic wave concept. If you want to explain this, then there is a failure. So then some different concept probably required for this light. So people, so it was the Max Planck who first came with this very jumping idea and very odd idea. So it is very, nowadays we digest, at that time it's very hard to digest. So he started to thinking light, what is the incoming light? It is not the electric field or magnetic field fluctuations. It is true, but we can think in the alternative thinking. The billions of particle actually is coming. Okay, so in terms of particle, if you think, and when you think about the particle, so particle information is basically energy and momentum. So as a non-relativistic case, energy is half mv square, p is mv. So this concept we know for the particle. So now if you try to think light is a particle, then this energy and momentum, this quantity is not the wave quantity, they are the particle quantity. So then Planck thought, okay, what are the wave quantity? That is nu and lambda. And any questions? Okay.
मैं तो मोबाइल से ही ज्वाइन कर लिया
Okay. So if any questions, then you can unmute. Otherwise, you can mute from your side. Okay, so this nu and lambda, they are basically the wave quantity. So Planck thought there should be some connections. So nu and lambda, they will be connected with this particle quantity, energy and momentum.
Smita,
And
switch on your
then,
camera.
and then,
Hello. If you have a question, a brief question, you may ask in between. Otherwise, please keep it muted.
Smita,
Hello. Maybe you can type in the chat box because the voice is not audible, and we can take up the question. Otherwise, please keep the microphones mute.
okay. So these are the connecting relations. Planck assume that energy is proportional to this frequency, and actually this proportional constant went really an earthquaking constant, because it is becomes a universal constant. It is not just a random thought. His thought become really he discovered a universal constant for that. So H, you know, that Max Planck and the Planck constant. Now, so when we started to accept this fact, okay, light is a billions of photons with the energy h nu and momentum h by lambda, and if you go to the its thermodynamical treatment, then actually people able to construct these curves. So then it become really surprising that now we are in very confusion. So we have to think light is a particle, and also we call them as a photons. So along with this black body radiation, there
connect
are
your
other
camera.
phenomena, and there also we have to think this same concepts, and light is a particle, the photons. So there is
She's
a
not visible.
photoelectric effect, there is a Compton scattering. So if you want to explain this phenomena, then these are the scientists who this Compton is discovered experimentally, and Einstein theoretically explained this effect. So let me just tell one by one very briefly what are the phenomena. So it is if you consider light basically is a billions of particles, photons is coming. So this green, I'm assuming they are basically the photons, each particles. And phenomena is that if it is incident here, and the electron can eject. Okay. So this phenomena actually, if we consider light is a wave, is electromagnetic wave and oscillating things, then actually whatever the results we are getting, so I'm not going to the details of those result things because it is itself a one lectures explaining the photoelectric effect. But if you consider these classical things, actually we fail to get the results. So there's something is wrong. So but if you, so Einstein shows, if you say this h nu different photon particles coming, and their energy is investing with ejecting with this electron, and there is called the work functions. So if you subtract the work functions, you will get, so the excess energy will give as a kinetic energy of this electron. And if you think in that way, it is absolutely the all results is matching and everything is happening just like a magical things it is happening. So we have to accept, otherwise there is no options, because if we consider the electromagnetic wave, then we somehow not explain. Okay, so for these phenomena, this photoelectric effect phenomena, for this Compton scattering and black body radiations, we have to accept those facts. So let me tell brief about the Compton scattering. So this Compton scattering is something like that. In the classical mechanics, we learned that the two body, that M1 and M2 body, if we collide, and how before collisions and after collisions mechanism, we know that how to deal this two body phenomenon. So similarly, if you consider light is a photon, is one body whose mass is 0, and energy and momentum, if you know the relations. So if you just demand the energy conservations and momentum conservations, and if you deal, then actually you can able to explain the phenomena. And this phenomena is very interesting. This phenomena actually not valid for the visible range. It is valid for the X-ray range because of this Compton length dimension. But if it is possible for visible range, if we assume, then it is very interesting that if you are using that red light, laser light, and incident on a free electrons, then in different angle you will see the different light. Okay, so some angle you will see the green light, some angle is a yellow light, some angle other light. So unfortunately, it's not happened in the visible range because actually it is deciding by the Planck's constant. So if you imagine some other universe where Planck's constant is different, then probably visible range also you can see this beautiful magic phenomena. So actually again here, just like photoelectric effect, if you try to explain it with the concept of classical electrodynamics, the electric field and magnetic field is fluctuating, and the fluctuating quantities role of the electron will be just oscillating. Then if you try to that way, actually we will fail to explain this Compton scattering phenomena. But if you try to imagine that this incoming light is the billions of photons is coming, and each photons have energy and momentum E equal to h nu and p equal to h by lambda, then you can easily able to explain. And also this black body radiations, as I described the earlier slide, that these lines, actually the classical lines, if you consider light is a wave, and Rayleigh Jeans tried to explain, but they failed. But when Planck's assume that light is billions of photons particle, and each photon have energy E equal to h nu, then you can able to explain. Okay, so up to that, I'm stopping here with these introductions of the photon concept. So let me briefly summarize. The questions was what is light, and that we know that in the earlier stage when the geometrical optics is discovered, so they suggest they just consider as a ray, just something is flowing, just focus on the directions, don't go too much deep. But when they go too much deep, the Huygens discovered that it is a wave with the different phenomena. Actually, they get the proof that diffractions and interference, and they demand that just like sound, some quantity is fluctuating with space and time. And we know that present days this is the branch of the physical optics. And later people go more deep, and actually the answer is hidden in completely different branch, the electricity magnetism, and they discover light is a fluctuating electric and magnetic field and electromagnetic wave. So nowadays it is documented in the classical electrodynamics, completely a big branch of the physics. And later we people shocked with some phenomena, the black body, to explain the black body radiations, Compton scattering, and photoelectric effect. There people try to think light is basically billions of photons particle, which moving with speed c, and its energy equal to h nu. And these are connected with the quantum mechanics, and light is also a relativistic particle. So actually whatever we know that energy is half mv square, that concept we have to go to the relativistic concept. There is a different relativity relations that was discovered by Albert Einstein. So those topics is related with those this fact. Now the last questions, if you say the what is light, rays or waves or particles, then answer is very difficult. Safely say no answer. But maybe we can take help of the big scientist Niels Bohr, who suggests that maybe you can think in that way. So there is a domain. Actually, we are seeing the different phenomena, and there is some domain probably light behave like a photons. There is some domains that the electromagnetic classical concept, if you use, you can easily explain. But if you go to the vice versa, then you may face lots of difficulties to explain, but maybe still one can able to explain in different angles or too much complicated path. But it is easiest way which domain it's behaving in which way. So try to accept that. In some domain, if it is behaving classically, so our electrodynamics is helpful. Some domain it is behaving as a quantum, so the photon concept is helpful. So here I'm finishing. So if any questions you have, you can ask or you can chat. I can also I can answer.
Oh, thank you, Dr. Sabya. So we will have questions. So one by one, please. So you can unmute yourself and ask the questions, and others in between may type in. So we can take it.
Good morning, I'm Dr.
Okay, so we have a question by Dr. Piyush Vishwakarma, and he says that since light is an EM wave, then how photons are different from graviton?
Okay. So okay. So actually, we should not connect. Actually, when we consider the particle, so some immediately it comes to our mind that some mass or some elastic kind of. Actually, in very early stage, Newtons also consider that light is a particle, but their conceptions is because like Newton is always think about the some that non-relativistic and mechanical kind of things. There is some elastic phenomena. The reflections also Newton have tried to explain in that concept. This particle is some mass or anything, but actually it does not goes because for that case he has to consider velocity of light is particle is infinite. So in that case, we should not consider particle means that whatever the ordinary electrons and protons, they have a mass, they have a velocity less than c. So that kind of concept actually we should not take. So this is some special particle, and its velocity is actually the extreme velocity of the universe, because universe have a upper limit of the velocity, which is c, 3 into 10 to the power 8, this the speed of light. And this graviton things actually we should consider completely different. So that is the different thing. It is connected with the quantum field theory. So there actually there's lots of things to tell, but let me tell very briefly. So in quantum field theory, this is a very advanced branch of physics. There they completely define the force in completely other way. So generally, if two magnets attract this force, we can understand there is a field of lines or something like that. But there they think the force actually the responsible. There is some exchange particle, means some messenger will give the informations actually from one particle to another particle. That messenger will say you have to attract or you have to repulse. That informations actually that messenger propagate. So that things it comes from the little bit of complicated mathematics, and this interpretation of mathematics is something like that. There is a messenger particle who tell you that you have to be forced.
There's a follow-up question that says gravitons are massless. So I don't know. So in the same light.
Okay.
So
Hello, sir. Can I ask another question?
yeah, go ahead.
Yes, sir. Sir, sometimes we are talking, means we are always talking light is a rays and it is a electromagnetic radiation. Now, how I explain which electric field or magnetic field is active component. So what can I would like to ask you which component is actively participating is more electric or magnetic?
Actually, both are there, but you can know the strength that actually electric and magnetic field, they have a relations. Means
Yes,
if you
that is pointing. Yeah.
so accordingly they will react. Okay, so
Sir,
if,
excuse me, sir. Can I answer? Can I
yes,
try?
yes,
Okay, sir.
please.
Good morning, sir. Sir, actually, component we can say here because they are only the that means it gives the influence. It is not a component. Electric and magnetic field, they both are perpendicular to each other, and
Yes,
we
yes.
can get the influence because here in physics we don't have any like we are saying light is an energy, but energy it can be only felt. It cannot be visible. It is invisible. It doesn't contain any particles. So here we can't say that it is which component is more and which component is less. It both have equal importance when we take it in the form of magnetic field or in the form of electric field.
Okay,
I think.
Okay, that means
Thank you,
okay. Thank you. Thank you.
thank you, sir.
okay.
Thank
So any more questions?
Okay, any more questions? So there's one more on the chat.
Hello.
Hello,
Hello.
who is this? Please tell your name.
Sir, yes, sir, this is Dr. Piyush, sir. Hello.
Yeah, ask your question.
Sir, since light is an EM wave and light and particle both, sorry, wave and particle both are moving together. So what should be the minimum amplitude of the light if it is traveling, very large distance? So amplitude of the wave will reduce simultaneously.
Yes,
So
yes.
what should be the minimum amplitude? It should be less than particle size or it's, equal to particle size?
Okay, so actually, you
Can
see
I
that
answer? Sir, can I answer, please?
Please let the speaker answer first and you may come in later.
Okay, okay, sir. Thank you, sir.
okay. So this the intensity is decaying thing. So you know that from source as you go far, the intensity is decaying. So that things into different approach also you can explain. So for electromagnetic wave, when you consider, so it means the amplitude is decaying with space, and so it's the amplitude by r something relations like that. But if you want to explain in this particle concept, then the numbers of photons actually it will decaying. Okay, it's something like that. So this way maybe there will be problem if you try to parallel way if you tell those quantum and classical, then you may face some problems. But if you want to explain some phenomena, then you have to consider the necessity of which domain. So if it is a classical, you can able to explain, then classical conception is okay. But if it is you need the quantum concept and to explain, then you have to consider. So as I told in the last point in that. So is it little bit of makes sense, Pius?
Hello.
Yes, sir.
Okay. Thank you.
Hello. Good morning, sir.
Huh?
It's Dr. Raghavendra.
Raghavendra.
Just I posted a question, sir. In Compton effect, the photon gets scattered with a
So
graphite.
can you speak little loud?
Yeah, in Compton scattering, the photon gets scattered, and also the electron get recoiled. But in photoelectric effect, after transferring energy to this electron, what happens to these photons? Where do they go?
Can you repeat again after?
In the photoelectric effect, there is an interaction between photons and electrons. Am I right?
Yes.
The photon energy will be transferring to electron. Okay, then what happens to the remaining photons which they lost their energy to electrons? Where do they go?
Okay, so that is actually the electron gate, no, the kinetic energy. So let's say 100 amount of energy have a photons and it deposit on the electron, and let's say electron have a work function 60. So then 100 minus 60, the excess 40 energy. So you consider any unit, then 40 is goes as a kinetic energy of the electron. So half mv square. So that is why the
Okay, right.
electron will flow.
Okay, then
So
there will not be there will not be any existence of photon at all. They just do
Yes,
the
yes,
decay.
it will completely absorb. Yes, yes, there will be no existence. Yes,
Oh.
yes.
Okay, there is an announcement now. So the AICTE has told us, requested us that today there are like 24 FDPs they are that have started today together. So for them, they have organized a joint all India level inaugural ceremony, and that's why this first session we are like stopping at 11, and then you may go at the YouTube link that I have shared on the WhatsApp group. So you may join that inaugural ceremony organized by the AICTE. And then please remember to come back for the next session by Dr. Srisha Vempati at 11:45.